Welcome to my channel. Today this is the video of the chapter of Cartesian, Subtangent and Subnormal, and see here is a 4 to 9 problem in my first video to the chapter of Subnormal, Subtangent. There was a 3 problem, and see. The first problem, find the length of the subnormal, subtangent, tangent and normal to of the curve for x is equal to a theta plus sine theta. Okay. See, this is number 1. X equal to a within the bracket theta plus sine theta. So dx d theta a into 1 plus cos theta. Okay, and y equal to a into 1 minus cos theta dy d theta a into within the bracket sine theta. Now find here dy dx, that is dy d theta dx d theta actually. Okay, and this is here a sine theta, and this is here a into within the bracket 1 plus cos theta. Okay, and this is here 2 sine theta by 2 cos theta by 2 by 2 cos square theta by 2. So this is here tan theta by 2. Okay. Now subnormal, length of subnormal. Length of is equal to y into dy dx. Okay, y into dy dx. So y means here a minus cos theta, and dy dx, this is here tan theta by 2. A into 2 sin square theta by 2. Okay, this is here tan theta by 2. This is here tan theta by 2. Okay, actually 2a sine cube theta by 2 and sec theta by 2. This is the subnormal, length of subnormal. And the subtangent. Therefore the is equal to y by dy dx, and y means here a into 1 minus cos theta by tan theta by 2. And this is here a into 2 sin square theta by 2 into cos theta by 2 by sin theta by 2. Okay, so 2 sin theta by 2 cos theta by 2, this is sin theta, and this is the length of subtangent. Okay. Now we have find here tangent, length of tangent. Length of tangent is pt, that is under root, this is y square plus tm square, y square plus tm square. This is y square plus tm. Tm is the length of subtangent. This is y square by dy dx. And take a common y square, so this is y here. And now this is root over 1 plus dx dy whole square. This is your y into this is cot square root over 1 plus cot square theta by 2. And this is y. Y means there a into 1 minus cos theta and 1 plus cot square, this is cosec square theta. 1 plus cot square means this is cosec square theta, and cosec square theta means cosec theta, and cosec actually theta by 2. And now see a into 2 sine square theta by 2 into 1 by sine theta by 2. This is twice a sine theta by 2. Okay, this is the length of tangent, and similarly you can find the length of normal, and that is their Pn, and Pn is equal to y square plus mn square. Mn is this y square and dy dx whole square, take on y, and under root of 1 plus dy by dx whole square, and this is the value of dy by dx tan square theta by 2, and the value of y here is a into 1 minus cos theta, and this is sec square theta means sec theta. Okay, theta by 2. So this is 2 and this is 2a sin square theta by 2 and sec theta by 2 actually. Okay, this is the answer for question number 4. Now see the calculation carefully. Okay. Now question number 5. Find the value of n so that the subnormal at any point in the curve x into y to the power n equal to a to the power n plus 1, and take a log on both sides, and now differentiate both sides with respect to x. This is 1 by x n by y dy dx equal to 0. So this is that dy by dx is equal to minus 1 by x into y by n, y by x into 1 by n. Now dy by dx at x1 comma y1, and that is equal to y1 by x1 into 1 by n. Okay, and we have to find subnormal. This is a subnormal. Find the value of n when the subnormal at any point on the curve may be constant. Then find the value of n. Now the length of subnormal, length of subnormal is equal to y into dy by dx. So y1 into dy by dx, this is minus y1 x1 1 by and this is equal to square by, okay. Now x1 comma y1 lies on the curve, so x1 into y1 to the power n is equal to a to the power n plus 1. So therefore we find here y1 square by x1. x1 means a to the power n plus 1 into y1 to the power n into 1 by this. So see here, minus 1 by n into, this is a constant, and also the power of y1 here is n plus 2. So since therefore y1 to the power n plus 1 n plus 2 is equal to y1 to the power 0 actually, as subtangent is constant, as since the subnormal is constant. Okay, so this variable will be absent, and it is possible when and this be a 1 like y1 to the 0. So therefore you can write here n plus 2 is equal to 0, that is n equal to minus 2. Okay, so this is the solution of that. Now in the term in the board I will have to solve the question number 6. This is a curve, this is a tangent, and this is a normal to the curve. Okay, this angle is called psi, and tan psi is equal to d by dx 0. Okay, at xy. So now the equation of tangent at xy is y minus y into tan psi into x minus x on, and the equation of normal, that is y minus y minus 1 by tan psi into x minus x. Since this is P1, this length is called P1. P1 is the perpendicular distance from origin to the tangent. So now P1 is equal to perpendicular distance from 0 0 to the tangent 1, that is equal to 0 minus y minus tan psi into 0 minus x by root over of 1 square plus minus tan psi square. See the calculation. You have to take a common to the take this term to the left hand side, and the coefficient of y is a 1 and the coefficient of x is a minus tan psi. Okay, so that is a square plus b square, and that is equal to y minus plus x into tan psi whole divided by 1 plus tan square. This is sec square. Sec square. This is sec square. And this is here x psi minus y into cos psi plus x into sin psi by 1, and this is your x into sin psi minus y into cos psi. Okay, now P2 is the perpendicular distance from 0, 0 to the normal. This is 2, and that is equal to, we can transfer this as a 0 minus y, and this is plus cos psi into 0 minus x, and that is your 1 plus 1 square plus cos square psi, and this is your minus y minus minus plus x cos psi by cosec psi. If we simplify, then what happens is 1 plus sin psi plus x into cos psi. So 6, 5 and 4 are done again. Okay. See. And next problem, question number 9. This is 9. If the area is x square by a square, y square by b square equal to 1, and x is equal to a sin phi, then show that ds d psi d phi is equal to a into root over 1 minus e square into sin square phi here. Okay. And now x square by a square, differentiate this, and we get here dy dx is equal to minus b square by a square x by y. Okay. And now we have to find ds dx, and that is equal to root over within the bracket of 1 plus dy dx whole square. Actually, you know, ds square equal to dx square plus dy square. It is. ds is a very small distance, so we can apply the Pythagoras rules. So from that we can write is this, and from that we find the ds dx is this, and find dy by dx is value is this, squaring both sides. And now it is given that the x equal to a sin phi. So put on the ellipse in place of x, and then we get here a y equal to b cos phi. So we have now find x by y. So this is x equal to a sin phi by b cos phi divided by this, and then we get here a by b tan phi. Okay. And now differentiate x is with respect to phi is a cos phi. Okay. Now ds query is our ds d phi, and that is ds dx and dx d phi. Okay. And the value ds dx is this. Okay. Substitute in this place of that, and dx d phi, and that is equal to a cos phi. Okay. And take a LCM, sin square by cos square, or take a LCM, this is cos are cancelled, so is this, and cos square means 1 minus sin square, and take a common sin square within the bracket. Here is minus 1 plus 1 minus e square, so is this, so you get here 1 minus e square sin square phi. Okay. So this is the question number 9. Okay, now follow the question number. Follow the question number 8. This is we have to find the value of ds dx actually. So this is equal to 1 plus dy dx whole square and under root of that. Okay, now here y square is equal to 4ax, so twice y, dy dx is equal to 4a, and this is your dy by dx is equal to 2a by y, and now this is your root over 1 plus this 4a square by y square. So 4a square by y square means 4ax. Okay, so we got the answer 1 plus a by x. Actually a by x here. So this is a root over a plus x by root x actually. Now for second, and this is here y is equal to a by 2 e to the power x by a and e to the power minus x by a. So dy and dx a by 2, and after derivative we get here 1 by a and minus 1 by a, so we take a common 1 by a here, and this is x by a and minus e to the power minus x by a, and this is 1 by 2 e to the power x by a minus e to the power minus x by a. Okay, now ds dx, okay, and root over of 1 plus dy dx whole square. So this is 1 plus 1 by 4 e to the power x by a whole square. So this is 4 of e to the power x by a plus e to the power minus x by a whole square, and this is minus 4 actually. So 1 by 2 e to the power x by a with a minus x by a, so 1 by 2, and this is equal to 2a by y, 2y by a, so y by a. Okay, see the solution here. Okay, now proceed to the 7, and it is needed to solve the question number 7 also, 7 in 6 also. Okay, after that we follow the 7 here. So in the previous calculation there was a solution of 6, then after we solve question number 7 here. See, very easy question. So in the above cases, the curve for this, so that p1 square put times p2 square equal to a square. Actually p1 means the perpendicular distance from origin to the tangent. Now on differentiate x by 2/3 and y by 2/3 equal to a by 2/3. So this is 2/3 and x to the power minus 1/3, and this is 2/3 y to the power minus 1/3, and this is here dy by dx is equal to 0. So therefore dy by dx is equal to, actually this is here 1 by 1/3 by x by 1/3. Okay, now this is differentiate. So here is the equation of, now the equation of tangent is y minus y into dy dx into x minus, okay. So this is here, and therefore p1 is the perpendicular distance from 0, 0 to 1. Therefore this is mod of 0 minus y minus dy dx and 0 minus x actually by under root of, and this is here, and this is here 1 square plus dy by dx whole square. Okay, and now see, this is here minus y plus x into, and dy by dx is this y to the power 1/3 by x to the power 1/3. Okay, by under root 1 plus, and this is the square of that. Okay, 2/3 by x to the power 2/3. So this is equal to y plus x to the power 2/3 and y to the power 1/3 by, take LCM, x to the power 1/3. So, and this is here x to the power 2/3, y1 to the power 2/3, and take a common x to the power 1/3 and y to the power 1/3. Then after x to the power 2/3 and y to the power 1 minus 1/3, this is 2/3, and over root over x to the power 2/3 and y to the power 2/3, that is x1 to the power 1/3, y1 to the power 1/3. This is a to the power 2/3 by a to the power 1/3. Actually, if we put the value of this is 2/3, then we got this. Okay, so this is x to the power 1/3, y to the power 1/3 and a to the power 1/3. Okay, now P2. Now the equation of normal is, so y minus y, actually minus 1 by dy dx into x minus x. This is here, so y minus y plus dx dy. Okay, x minus x equal to 0. So P2, perpendicular distance from 0 0 to 2, then P2 is equal to, so this is here 0, this is minus 1 plus, actually this is here dx dy at minus x, and this is here 1 plus dx dy whole square. Okay, now see, this is minus 1 minus x and value of dx dy. This is dx dy are reciprocal to that, so you can write here x to the power 1/3 by y to the power 1/3. Okay, we got here minus, so this is here we got here plus. So C, same as 1 plus, this is dx dy, so this is x to the power 2/3 and y to the power 2/3. Okay, and this is equal to, actually if we take our LCM, then we got the x1 to the power 1 plus 1/3, that is 4/3. Okay, y1 to the power 4/3 actually. If we multiply this and take a LCM of that, so the LCM or y to the power 1/3, 1/3 are cancelled, and on the overload of this is a to the power 2/3 here. So simplify x to the power 2/3 minus y to the power 2/3, and the other factor is a to the power 2/3, and overload of a to the power 2/3, and this is a 1/3. So x to the power 2/3 minus y to the power 2/3 and a to the power 1/3 actually. See, this is P2. Now 4P1 square plus P2 square, 4P1 square, this is here P1, this is P1 square. We can write here x1 to the power 2/3, y1 to the power 2/3, a1 to the power 2/3 plus P2 square, a to the power 2/3 square, 2/3, y to the power 2/3 whole square. Okay, this is 4, x1 to the power 2/3, y1 to the power a to the power 2/3, squaring both sides, a to the power 2/3, x to the power 4/3, a to the power 2/3, y to the power 4/3 minus twice AB, x1 to the power 2/3, y1 to the power 2/3, a1 to the power 2/3. So these two term, okay, no, this will be a plus. Okay, so and take account a to the power 2/3 here. So x1 to the power 2/3 and y1 to the power 2/3, and this is whole square. So a to the power 2/3, and this is a to the power 4/3, and this is 6/3, and this is a square. Okay, so I think all of you better understood. Very interesting question. See carefully. Okay, bye.